Hello, welcome to the visualization class. In this tutorial, we are going to learn how to visualize social network by using Python. The first question is why we visualize social network. The reason we visualize social network is that as social net has become part of our life, it is very important for the data analytics to dive into the structure of the social network so that we can visualize the nodes and the links so that we can better find the influencers or the followers so that at the end of this analysis, we can better deliver the online service or better deliver the advertisement on social network, etc. So that is why visualization of social network is very important. So in this tutorial, we are going to learn how to transform this data into this visualization. Okay, so let's first analyze the data set. So this data set is stored as a CSV and it has three columns. A username follows who and the days. So username and follows who, they are the users. And the days represent how many days those link generated or how many days this link created. So first column username, each of the entry represent a user, and follows who means that this user follows another user. So let's say the first one, Annie, follows Carmen, and this friendship lasts 200 days so far. So that means Annie and Carmen are friends in terms of online social network, and they turn to have a stronger relationship. And the other column, Betty, also follows Carmen, and this friendship only has 20 days. So that means Betty follows Carmen, and they are new friends compared with Annie with Carmen. Of course, these days represent, you can think about that represent as the strength of the relationship. So what we are going to do today is to transform this CSV file to this social network graph. And we have the nodes and we have those edges. The nodes represent user, and the edges represent the connections between the user. And we also notice that the edge has weight, right? And this weight represents the level of the friendship or the strength of the friendship represented as days. Okay, so let's continue. Let's go to the Google Colab and we're going to practice how to transform this CSV file to the graphic structure. Okay, I'm going to stop share here and go to a new web notebook page in Google Colab. First, I'm going to load the data set. So let's go to the content, and then I'm going to upload a data called a socialmedia.csv in here, and then we're going to import some libraries. Okay, the first library we're going to import is pandas as PD. So this is for data upload, and the other library is for visualization, that is matplotlib pyplot as plot. Okay, next one, in order to visualize the social network or other type of graphic structure, we're going to use Networkx. Okay, so Networkx is very commonly used library to visualize graphic structures as an X. So that's all for the libraries. And the next, we're gonna load the data into Python. We're gonna define a variable called df, and that is pd.readcsv, and the name is social media.csv. Of course, this data set I attach that onto the comment section below. You can download and play with the code. Okay, so let's first take a look at the data. So the data is just what we learned in the previous session. So we have 3 columns: user, follows, and the days. Okay, so that is the CSV file, and now we want to transform this CSV file. We're going to extract the information from this CSV and to plot that or display that in a graphic structural visualization. So how do we do that? First, we're going to create empty graph, and empty graph, and that is, let's say, it's called G2, and this G equal to an X, which is from the Networkx library dot directed graph. So why we use directed graph? Because sometimes we want to visualize the direction. Let's say this Annie follows Carmen, so that type of relation is from Annie to the Carmen, right? So in order to visualize that direction, we're going to use a directed graph. Okay, so that is the empty graph, and now we're going to put all these nodes and the link to these nodes. To this graph. And how do we do that? In order to assign nodes and edges to G2 from the data frame, we're going to use G2 equal to nx from pandas edge list. Okay, this function from pandas edge list will transform the data frame into the network structure and extract the nodes and edges from the data frame. Of course, first we're gonna let Python know what is the data frame we're gonna analyze upon. So that is df. And second, we want to specify the source data and the target data. The source data, I mean the source node, and the target represent the target node. So of course, the source node in this data frame, that is the username, and the target node is follows who. So in order to specify this, we're gonna say source equal to, we just specify the column name. That's very easy. And the next one, we're gonna specify the target. Target equal to follows who. Okay, so that is how we extract the nodes information and put that into a directed graph. And next, after we have specified the nodes information, we're going to specify the edge information. Okay, in order to specify the edge, we're going to say, here we're going to say edge attribute, and this edge attribute argument equal to days, right? Because days represent the level of the friendship or strength of the friendship. The more days they are linked, they are more likely to have a better relationship. Okay, so that is how we specify the source node, target node, and edge information, so that we can pass all of this information and Python will automatically generate the graph for us. Okay, so let's run the code. Next, we want to testify if the graph G2 has all of this information. In order to testify this or evaluate this, we're gonna use say G2 dot nodes. So let's take a look at what happened. Okay, now if I call this function G2.nodes, I ask Python to print all the nodes for me. And we can say that the nodes for the entire data frame has Annie, Carmen, Betty, Dylan, Jessica, and Keith. that is all of the users from the data frame. And that is good. So that says we successfully put all of these nodes information and edge information to this G2. Okay, next, after we have this G2, we want to visualize that. And in order to visualize that, we're gonna use 3 steps. Okay. Okay, so first let's tell Python how we want to visualize this graph. What is the layout of this graph? So we're gonna set up the layout. The layout is just the style of the network visualization. So let's say pose, this represents the layout, equal to nx, the Networkx library, dot spring plot, a spring layout. So this spring layout is just a style of the network visualization. So let's pass G2 into this style and run the code. Okay, next, after we have the G2, we have set up the style. Next, we're gonna visualize the nodes, edges, and the labels. Okay, so that being said, we're gonna first use nx.draw network nodes. So this function helps us to draw the nodes. And the next, we're gonna use draw edges, Networkx edges, to display the edges. And then finally, we're gonna use draw Networkx labels. Draw network labels to visualize those labels, such as what is the node's name, what is the edge name, etc. So these are the 3 steps. After we integrate all of these 3 steps, then the whole picture will be displayed. And next, we're going to use plt.show to have the final result. Of course, if you run those codes, it cannot pass because we're going to specify those arguments inside of those function. Okay, inside of this draw network X nodes, we're going to pass G2 because G2 is the graph we're going to visualize. And then we're going to specify the pose, the style. Of course, we're going to deliver all of these into the edges and the labels because all of these functions require the graph you're going to visualize and the style you're going to visualize. So that is why we put all of these arguments information into this function. Okay, so let's run this code. So we can see this is just a very fundamental version of the visualization. And if we run the code, Python gives us a result. So we can see that Carmen and Annie has a link, Carmen and Dylan has a link, Carmen and Betty has a link. So basically, this graph just summarize all of information from the original CSV and displays the entire structured information for us. Okay, so that is the basic version. So upon that, we can improve those visualization a little bit so that it can look better. So first, we're gonna increase the size of the node. In order to do so, we're gonna say node size equal to, let's say, 500. Alpha equal to 0.5. So that means we're going to increase the node size and use the transparent color to 50% of the shade so that the node color is just lighter. So let's try it. Okay, now you can see that if we set the alpha equal to 50%, the color of the blue is just lighter, so that we can better see the name and the node name. Okay, now we can change that to 800. Okay, now it's better. And next we want to specify the weight. Now, if you take a look at this graph, you can find that the link between any nodes, just the link, they do not have the weight. Remember in the previous slides, we talked that the days should be involved into this social network visualization because it represents the strength of the relationship, but it doesn't show any information here. So that is being said, we need to specify the weights and add those weights to this graph. In order to incorporate the weights information into this graph, first we're going to extract the weights information from the graph. So let's create a new code in here and we call it weights. And the weights contains all of the edge information from the graph. So that being said, we're going to use an x dot get edge attributes, and this function will extract the edge information and store that into the weights. So in this function, we're going to put G2 here because G2 contains the edge information, and the edge is stored in the days, right? So we're going to specify the days, and then we're going to transform the results into the numeric value and using values. Okay, finally we're going to put that into a list. Why? Because the list information can further pass into this draw network edge so that we can incorporate the weight information in this existing graph. Okay, so let's first take a look at the weights. Okay, they are 230, 20, 50, 100, and 100. It's just all of this information from the last column. Okay, now we're going to put the weights into this network X edges, draw network X edges, right? In order to do so, we're going to specify another argument called weight, and the width equal to the weights. Okay, so that being said, the edge width will be the weights information. Okay, so let's run the code. Okay, so this looks awful, but we can adjust that. So basically, you pass the weights into the width so that Python already responds to the right answer. But the problem here is the weights are so big so that those edges will be too chunky to visualize. So that means we're gonna make this with a smaller value, or we want to rescale the weights information so that we can better to visualize that. So how do we rescale all of these numbers into a smaller version? In order to do so, I'm gonna type weights, and we're gonna divide 50 from the existing days. So that being said, weight equal to list I divided by 50. So, and for I in weights. So that means we're gonna have the existing weights and each element we're gonna divide it by 50 so that we can rescale the weights. So let's rerun the code, and now you can see the new weights, the rescaled weights will become smaller. So let's rerun the code. And that is better, right? So these are not trunky anymore and just a common link. And the thickness represents the strength of the relationship. Of course, you can adjust the color. In order to do so, we're gonna say edge color equal to, let's say, green. And then rerun the code. You can see that the edge color becomes green. So this is how we visualize the social network by using Python. All you need to do is to have a data frame or CSV file. We have specified the source node and the target node and the weight between the edge, and then you can have this visualization of the social network. I hope you enjoyed this video, and I will see you next one.